let f be the function graphed below. So what we have here is we have the graph of function f. All right, and this is going to be the key for the entire problem. And what I'm going to do in this example and in the next example, we're going to connect differential calculus and integral calculus. So we're going to show you how they are tied together and how they can actually work together. All right, so we've got the function f. So this f is made up of a piecewise function. So you have a horizontal line here, a line with a positive slope, and a line with a negative slope. And then it says g of x is equal to the definite integral from 2 to x of f of t dt. Notice the lower limit of integration on g. Now g is not the same thing as f of x. Somebody explain to me what g actually is here. So here's g of x. G of x is the definite integral from 2 to x of f of t dt. So what is g of x really doing? It's area under the curve of what? F. And what they've shown you is f. So to figure out what g is, I don't even know what the graph of g looks like. The graph of g might be a parabola. Okay, tomorrow we're actually going to get into that. The graph of g might be a parabola. It might be a disco curve. It might be a sine graph. It might be a, it's probably piecewise, but it's probably something a little bit different. And what is g the graph of? It's a graph of all the areas accumulated by the area under the curve of f. So if you were to actually plot out, we can get points for g, and I'm going to show you how to do that in A through D. You could actually get points for g, plot them out, and kind of project what you think the graph of g actually is. It has its own graph, and that graph is a plot of all the areas accumulated under f. Measured from where? Notice the lower limit of integration for g. The area is measured from 2 every time. So you're going to measure, and what I would do on the AP exam is I would always, when you look and they give you what I call the area collector function, or the accumulation function is what some textbooks call it, because it's accumulating area based on what x is. It's always measuring it from 2. So we accumulate area. So as it accumulates area, I would always label where it's measuring the area from. It's measuring the area from 2, that start value. That's why on the quiz, when you did that start plus displacement, you couldn't put a to x. You had to tell me where you were measuring it from, what x value. I'm going to really nail that down because somebody I still don't think get it. We didn't. I don't know why we're not getting it, but I want to make sure you nail that down, that you know that this is where it's measured from, that x start value. So from 2. All right. Part A, evaluate each of the following. So A through D are just going to evaluate the function g at a particular x value. Now, g of 0, here's the mistake a lot of people make. They think, okay, g of 0, that means I'm going to go over here to 0 and I'm going to figure out what the y value is. No, that's not the graph of g. What is that the graph of? F. To calculate g of 0, I've got to plug it into my function. So when I calculate g of 0, I'm going to have, according to this, g of x is a definite integral from 2 to x of f of t dt. Well, g of x, the x value gets plugged into the upper limit of integration. So I'm going to have the definite integral, write this down. You're supposed to do this with me today. This is an assignment we're doing together.
On this?
Yep, you can do it right in Notability. Okay, from 2 to what? What are we replacing x with? 0 of f of t dt. I want everybody to look there. So we've got the definite integral from 2 to 0 of f of t dt. Now, what this is telling me to do, to figure out g of 0, I need to find the area under the curve from 2 to 0. Well, let's remember here, how do we measure area? Remember, a definite integral represented the area under the curve. And we started with a Riemann sum. And we started estimating that area under the curve using a left endpoint, a right endpoint, and a midpoint. And we did a finite number of rectangles. Remember, it was based on a rectangle. And then what we said is we'll just pretend there's we won't pretend, but we'll take the limit as the number of rectangles approach what? Infinity, and that gave us the actual area. So everything is still based on the idea of a rectangle. A rectangle has a width and a height. So if we know there's an infinite number of rectangles here, okay, there's an infinite number of rectangles here from 2 to 0, here's what I want to talk about. There's a width and there's a height. The width can either be positive or negative, and the height can either be positive or negative. Because I'm going from 2 to 0, what is the width?
-2.
It's negative. And that's because on the x-axis, we're not talking about total distance, we're talking about displacement. So x's and y's can be positive or negative because it's based on direction. So when you go from 2 to 0, this is going to be a negative width. The height's positive because you go up. If I was to go down with the height, what would the height be? negative, and if I was to go to the right with the width would be what? What if I went to the right, or sorry, let's say I measured from 2 to 0, but this graph was below the x-axis? The area is actually positive. Here the area is actually going to be what? Because we're measuring from 2, what's the area actually going to be? It's actually going to be negative even though it's above the x-axis, because what's the property we learned the other day? Flip the switch. You got to flip the integrals and throw a negative out front. And somebody asked me earlier today, I wasn't in this class, but do I have to, can I put the negative later? No, you need to flip it before you do FTC. If you do not flip these, your f of b minus f of a is not going to work. You have to have the larger at the top and the smaller at the bottom before you can do your f of b minus f of a part. Now, we're not going to get to do our f of b minus f of a. Can anybody tell me why?
Because you don't have f of t.
You don't have f of t. You don't have the equation for f of t, so I can't do this algebraically. What am I going to have to do to calculate this area under the curve? I can't do it algebraically. How am I going to do it? Using the graph. And what am I going to use to calculate the area under the curve? Because I don't have an equation. I don't want you to estimate. So how am I going to do this? We did it last Thursday night. Rectangles, triangles, and trapezoids. You're going to actually do it with geometry. You're going to have to do these areas geometrically. So this one right here, if I want to calculate the area from 2 to 0, first of all, I'll flip the switch, make it negative, and then all I need to do is know that the area is going to be negative something, okay? And I just calculate that area from 0 to 2. Well, from 0 to 2, this is a rectangle. What's the width of the rectangle? 2. What's the height of the rectangle? So what's the total area of that rectangle? So the answer is what? -4. G of 0 is -4. So we have 1 point on the graph of G now. So if we were to plot a graph for G, I didn't do this in the other class, but I'll do this. We know that 1 point on the graph of G is -4. I can plot that point. Okay, that's G. We'll call this G. G of x, the graph of G of x. You don't have to do this, but we'll do it just for investigation purposes. All right, I want you to try G of 2 right now on your own. Go ahead. G of 2. G of 2. That one's not going to take very long. Shouldn't. Everybody get a whirl real quick, and then we'll get the answer in a second. Okay, so G of 0 was -4. I'm going to keep these.
Just calculate the area at that point.
What now? You just figure it out. I'll say what it is in a second. All right, what do you guys think? 0. The area is 0. Why?
Because it's the same line.
Because the width of the rectangle, there is no width. And if you have no width, you can't have an area of a rectangle. Rectangle is based on width times height. So if there's no width, there can be no area. All right? There is no width at all, so you don't even have a rectangle. You have a rectangle, but it's at a specific point, which is really, it's not. It doesn't have a width to it. So the area is 0. So G of 2 is 0. Now we got another point. Let's plot that point. All right, let's do 2 more points. Do G of 4 and G of 9 real quick on your own. G of 4 and G of 9. One of these, I think you're going to have to do a trapezoid, and I want you to do the trapezoid. I do not want you to split it up into a rectangle and triangle.
How'd you get 0 for me?
2 to 2, that's a property we learned. Learned it last Thursday. Definite integral from a to a of f of x dx is 0, because there's no width to the rectangle.
50 cents. 40 cents?
Maybe.
30 cents?
4 pennies.
I got chapstick.
Hold on. I tell you, I pulled tater tots out of my pocket yesterday and ate them.
Like your pants pocket? Food? Why do you have food in your pants pocket?
Because we were reenacting Napoleon Dynamite. Remember when he took tater tots out of his pocket?
No, I made it the first 20 minutes of the movie.
You did not watch the plane diagram.
What?
You missed a classic.
First 20 minutes, I just felt bothered.
Anyways, I didn't have it in my pocket. I put a plastic Ziploc bag. And then I kind of slid my hand in the Ziploc bag and I got them and I ate them right in front of them and they like, Peyton knew it was coming, but.
Happy birthday.
For those of you watching the video live, Tyler just left the building. Okay, G of 4. This is the definite integral from 2 to 4. Apparently he had my permission. F of t dt. All right, now remember, we're measuring from 2, so I just want the area under the curve from 2 to 4 now, and I don't need to switch. Welcome back.
I had to run down the hallway to get the 50 cents.
Okay. All right, that was good calls. So, sorry for talking bad about Tyler behind his back. All right, I'm just kidding. All right, so the area from 2 to 4. What is this shape? Trapezoid. Okay. Somebody said 4-sided shape one time. Lucky it wasn't this year. All right, so I'm not surprised. Sam probably said it. But which one? What's the area formula for a trapezoid? Gosh, gotta memorize this. 1/2 h times b1 plus b2. All right, need to know that for trapezoids. If they have you do, listen, if they have you estimate a definite integral on the AP exam, and they say use trapezoids, you better know the trapezoid formula, and they don't give it. Which ones are the bases? I went over this the other day. Parallel sides. So this is base, we'll call that one base 1, just pick. It doesn't have to be the smaller one. That right there's 2. This one's base 2. Just label one of them 1, base 1, the other one base 2. What's the height? Is it the slanted side? No, it's the one parallel. It's the one perpendicular to the bases. So this right here would be the height, and the height would be 2. So to calculate this area, it'd be 1/2 the height, which is 2, times the sum of the bases, which is 2 plus 3. So you're going to get 5. The 2's cancel, so the area is 5. So G of 4 is 5. Okay, so now we got another point. Over here at 4. You did it wrong. All right, G of 4 is 5. So look, looks like to me, right now, based on what I'm seeing, kind of looks like that G of X is a straight line. Have to see. And I wouldn't know for sure. What we're going to do tomorrow is we're actually going to curve sketch it like we did in our 20-question assignment, where you do a first derivative test, you figure out the relative extreme of where it's increasing, decreasing, then you do a concavity, figure out what's concave up, concave down, and your points of inflection, and you sketch based off that. Okay? All right, G of 9. What do you think G of 9 is? Anyone want to take a stab at it? G of 9.
Oh, you have to use.
You got to use multiple areas here. You're going to have to, because it's accumulating area all the way up to 9. So how much did it accumulate up to 4? What was the area here?
5.
That was 5, positive 5 to be exact. All right, we don't care about this one. Do we need to worry about the one from 0 to 2? No, because we're measuring from where? 2. So I don't care anything about before 2. What about from 4 to 7? That's a triangle. What's the area of that triangle? All right, area of a triangle is 1/2 base times height. The base is 3, the height is 3, you get 6, or 9, and then you get 9 times 1/2, that's 9/2, which is 4.5 if you want. That's positive 4.5. What about this one? I don't think so.
Absolute value.
No, absolute value here.
-2.
2. So it's -2. We do not want absolute value. Let me clarify when to use absolute value and when you don't. If I'm not asking for the geometric area, I'm only asking you to calculate a definite integral. They didn't ask me to do an area. They didn't say anything, find the area of the region. If they say find the area of the region, then you do want everything to be positive. Let's clarify. If they say find the area of the region, then you're thinking geometry, nothing's negative, everything's positive. But if they're only asking for you to calculate a definite integral can be negative or positive. All right, so we add all these up. 5 plus 4.5 minus 2. Good job. 7.5. Thank you.
That's what I got.
7.5. So then that looks like now, up over at 9, 5, 6, 7, 8, 9, up at 7.5, maybe there. Does it look like it's a line?
Yeah.
Am I absolutely certain? Probably not absolutely certain, but most likely it's probably a straight line. Okay? At least in this part, now, there's something weird happening here because you got a corner and that might affect something, but it kind of looks like that g of x is probably a line. Now, what does g of x represent? It's a plot of all the areas under the curve. So that would actually plot out every area, not just from 2 to 4, but from 2 to 2.1, from 2 to 2.2, from 2 to 2.3, from 2 to 3, from 2 to 4, to 2 to 5, to 2 to 7, to 2 to 1,000. It just calculates every area and then plots it out on a graph. It's a plot of the areas under the curve measured from 2. Okay? And it's called the accumulation function. All right, so that's what we did for A through D. We just evaluated the function at particular x values. Pretty easy, right? The next part's even more interesting, because here's where you start connecting derivatives to integrals. Okay? So to connect integrals to derivatives, what you need to understand first, can I erase some of this? I'm just going to go back and write the answers. Can somebody tell me? G of 0 was what? Negative 4. What was G of 2? 0. What was G of 4? Huh? 5. What was G of 9? 7.5. I'll probably need that stuff. I don't know. Might need it. All right, now, this is the part they didn't really listen very well second hour. We got it. We finally got it, but they didn't listen up front. I want you to listen up front a little bit better than they did. All right, they're going to start to ask questions about the derivative, the first and second derivative. The first question to ask is, what's g prime of 4? In other words, they want to know the slope of the tangent line of 4. Now, we know that probably g of x is a straight line, but it might not be straight. We're just kind of assuming because we looked at 4 points and it looks straight. Do we know for sure it's a straight line? No. So they're wanting to know the slope of the tangent line at 4 function g. What do you think I taught you FTC Part 1 for? I taught you FTC Part 1 so you could do the derivative of an integral. How do you do, if that's g of x, let's come down here, and I'm going to tell you right now, in the AP exam, you always get points for this right here, even though it's not asked. If you will, whenever you see an accumulation function, if you'll write, the first thing you should do, and we're going to do it for response tomorrow in this very beginning class with your plan groups, if you will take the first and second derivative, even though you hadn't even answered any questions, they'll give you 2 points for it still. Because it's implied. You have to do it to be able to do other stuff. So if you will write down what g prime of x is. Now, how do we do g prime of x? If this is g of x and it's an integral, how do we do the derivative of an integral? You just did questions 13, 14, and 15 on your quiz. It's just f of x. Oh my gosh. That's so slick. It's just f of x.
What'd you say?
I said, isn't that slick?
Oh, I thought you said.
Yeah, you would. All right, g prime of x. I've heard your lunch
That's
conversation.
so sway.
Oh.
These are in our lunch conversation.
I know, I just teased you. G prime of x is equal to f of x. Okay? That makes sense? All I did was plug in the upper limit of integration and multiply by the derivative of the upper limit of integrations, which one? Now, let me just hypothesize here for a moment. Let's make it more complicated and show you what you would do if you didn't have an equation. And I kind of baffled them this morning, so this is just a side note. I'm chasing down a little rabbit, okay? You ready? Let's go get Peter. Cottontail. All right, g of x, watch. If I was to change, totally nothing to do with this problem. Just a little extension. This is an extend and learn more, okay? It's a bend and snap. All right, here we go. Only the girls got that one. All right, 2 times, let's say it's 2x, okay? Bend and snap. All right, f of t dt. Let's say I want you, I'm just gonna, let's go out about 4 or 5 derivatives and watch. There is a pattern here on this one. I did this one last hour and I thought it was really cool. All right, find the second derivative for me, or first derivative for me. How would you find the first derivative?
2x
F of 2x times what? 2. Beautiful. Find the second derivative for me.
I don't know.
Find the second derivative.
4x.
You are correct. You do not have to be turned into dust like in Indiana Jones' Last Crusade. All right, f of 2x times 2. You have to use chain rule on this now. So you can do the derivative. Jaleesa. You have to do the derivative symbolically. Okay? You have to do the derivative symbolically. All right? So watch this. It'd be f prime of 2x times the derivative of the inside, which is what? But there's already a what there? What do you think is going to happen on the third derivative? It's going to be another 2. Let's see. G double prime or triple prime of x. We're going to go second derivative, chain rule again, but then multiply by the derivative inside again. Now how many 2's are there? Now, somebody write me a formula for the nth derivative.
F to the number.
All right, so the nth derivative, ready? If I kept going out, the nth derivative of x, or the nth derivative of g, would be what?
F to the n minus.
Ooh, f to the n minus what?
1 prime.
It's going to be 1 less of 2x
times
times
2 to the n.
Times f prime of n.
2 to the n.
Yeah.
That's pretty sweet. The reason I did that, I saw a multiple choice question like that on the AP exam last year. And it was with sine and cosine, and you had to figure out a pattern. And it actually had a factorial in the answer. Does anybody remember n factorial? Like 4 factorial is 4 times 3 times 2 times 1. You went out like 4 derivatives, and you started to see a pattern. That it would always be the next derivative up, n. And then it was like 4 times 3 times 2 times 1. The next time it was 5 times 4 times 3 times 2 times 1. Then it was 6 times 4 times 3, down. And then you had to figure out the pattern, and then you answered it because it wanted the nth derivative. And then I've seen them do things like, all right, once you see a pattern, find the 98th one. Are you going to sit there and do 98 derivatives? No, you're going to figure out the pattern and just say, oh, 98th derivative? All right, 98th derivative. What would the 98th derivative be? You guys just told me what the, so it'd be g 98th of x equals
F to the 97.
f 97 of x times 2 to the 98. Pretty slick. Pretty cool stuff. Now, has nothing to do with what we're doing here. I mean, it does, but let's go to our easy one. So this one didn't really have a fun pattern. Okay, you just plugged in x and it was boring. Now, somebody tell me what the second derivative would be because we're going to have that in a second. All right, so back to this. So we found the first derivative of this just by plugging in x. So g prime of x literally is f of x. You know what that means? That means the derivative of this integral is just this graph. You are looking at the derivative of g. That's magical. Because look how easy it's going to make it. G prime of 4 is really what? No.
Sorry, 3.
Slope is derivative. We'll get to that. So g prime of x is not the slope, it's just the graph. So I'm just going to literally look at the graph. So g prime of 4 is just really f of 4. I'm not looking for slope, I'm just looking for
So it's 3.
it's a point. It's just saying, what's the point there? 3. That's it, done. That's the slope of the tangent line at 4. That's how we found the slope of the tangent line for g. Okay, the next one, if you want to find g prime of 7, it's really that's why they give you points for this. They will give you 2 points for this, even if you can't answer A through D on that free response. You don't know how to do anything. If you can do that right there, they'll give you 2 points. They do every year. Just because you know, first, what you're proving is that you know fundamental theorem of calculus part 1, and you know how to write derivatives symbolically. And it's implied. You have to have it to answer the questions. If you don't have this, you can't answer the questions. Now, to me, if you get this, you got a really good shot at answering the questions if you understand that. All right, what's g prime of 7? It's the same thing as f of 7, which is 0. Okay, pretty cool. All right, I need to scroll down, but I'm going to have to erase some stuff, I think. So what's the next question ask? All right, what's the maximum of g from 0 to 9? Just erase. You guys are going to have to keep track of this now.
Can you
I'm
just
erase.
do this by looking graphically?
Here's the deal.
Who's
You've
not
got g prime of x is I need this, equal to f of x, and we got g double prime of x is equal to f prime of x. Okay. I don't know if I need this one yet, but I definitely need this one. All right, what is the maximum? This one, English people. What are they implying if I just say maximum? I am absolutely asking for absolute maximum. It's implied. They didn't ask for relative. They said, what is the maximum value there? It's implied that they don't just want any maximum, they want the absolute. This goes to extreme value theorem. And how do I know it's extreme value theorem? Because I'm starting to talk about absolute extrema. Absolute. What was the most important thing for the extreme value theorem to guarantee an absolute max and an absolute min? Let's see if you know the theorem.
Continuity?
Has to be continuous on the
Closed interval.
closed interval. Is it continuous on the closed? Well, do we have a closed interval? We're kind of making the assumption that G is continuous. We'll make it, okay? Reason I can make that assumption is because this happened to be the derivative, f of x happened to be the derivative of G, and there is no discontinuity in f, and if there's no discontinuity in f, which happens to be the derivative of G, then G had to be differentiable. And if G is differentiable, what does differentiability imply? You see how I got to the, see how I could be a lawyer. You see how I got to the point where I could show that, here come, you can't handle the truth. You see how I basically proved that G had to be continuous? Because F is G prime. If G prime is continuous, G has to be continuous. Because differentiability implies continuity. So therefore, it is continuous on the closed. So extreme value theorem applies. Who remembers what you check when you're checking for absolute extrema when you're doing extreme value theorem? You gotta go look for, you gotta look for critical values. Yes, yes sir, gotta look for critical values. What else? You can't just check critical values. You gotta check endpoints. You gotta check endpoints and critical values. So I need to know, first of all, we need to know critical values. Where does G prime equal 0 or undefined? Alright, let's look at the graph. Is there anywhere where G prime is 0? Like literally, this is G prime, so is there anywhere where it actually equals 0? At 7. Now, we know that this is out of the question because we just said it was continuous for G. So you wouldn't even be looking at this. If extreme value theorem works, you won't even have to consider this. So you have one critical value. You still with me? Somebody, yes, no?
Yeah.
Okay. So now I got to check critical values and endpoints into the original function. I need to plug them into the original, figure out the points, and see which one's the biggest and which one's the min. And people are like, how do I justify this? You are justifying this right now by taking and plugging in your critical values and your endpoints. This is the justification. This is all you need for the justification. All you need to show is that I checked all the critical values and the endpoints, and the largest is the max, and the smallest will be the what? All right, we have G of 0. What was it? I think we did it in part A. What was it?
-4.
What was G of 7? We didn't do that one, but we did G of 9. Who remembers G of 9? I do, 7.5. G of 7 we can figure out. I think we figured out these areas. I think this was what? This first one was what? 5? This was what? 4.5? And this was -2. So what is the area from, what's G of 7? Well, it's the area from 2 to 7. 9.5. All right, which one's the max then? There's your max.
We already know that because that's the only critical value involved.
But it could have been an endpoint. What if this would have went back above? 9 would have been the max. This would have gained even more area. It would have gained area 5, and area 4.9, and even more positive area. So this gained area, lost area, so it had to be 7. What's the min? -4. That answers the next question. So you see how I went about that? Okay? And I know it's not totally something I think you can right now do on your own, but I think you can get there. Last two questions. Where does it concave down? Justify and write the equation of the tangent line at 4. Let me go back up here. Concave down. So that, what question is that? H? Is that right? I? No mouth, not really well. I, concave down. All right, how are we going to do concavity? Second derivative. All right, the first derivative, again, was f of x. What was the second derivative?
Prime.
Now, talk to me, Peyton. What are we going to look at if we want to look at the second derivative now?
The slope of that graph.
Okay, this is G prime. So if I want to look at G double prime, I need to look at the slopes of this. So let's figure out where G double prime is 0 or undefined. Now it can be undefined because we're past this.
How do you do that with that point where like that line from like 2 to, or from 0 to 2?
All right, what is 0 to 2?
So 0.
It's all 0. So G double prime equals 0 from 0 to 2, actually. Where else does it equal 0?
Would it be at 4.3? What would it equal at 4.3?
I'll talk about that one in a minute.
Oh, that's undefined, isn't it?
Yeah, 4 is undefined. What else? Anywhere else where the slope is 0 off of this graph? Nowhere. So this is interesting. We haven't done a sign analysis like this before because we have a whole interval where the slope is 0. we have a horizontal line. There's a bunch of places where it equals 0. So here's what you're going to do. You're going to go 0 to 2, 2 to 4, and 4 to 9, just like normal. But what do you put for the sign for 0 to 2? 0. It isn't positive or negative, it's 0. On that entire interval, it's 0. What about from 2 to 4? Now you just look at slopes. Positive? Now this tells you where G double prime is equal to 0, positive or negative. It also tells you where G prime is increasing and you'd say increasing, decreasing, but I don't want to know that. I want to know where G is what?
Concave down.
Okay, so this says 0 says no concavity. What about 2 to 4? Concave up. What about 4 to 9? Concave down. So let's answer the question. It's concave down from 4 to 9. Give me some reasons. There's two ways you can reason this. You can say because G double prime is what? Or you can say because G prime is? That's it. Those are the two reasons you could give. I always do the G double prime. I just work with where you're at. I always work at the first line. Okay? Above or below. So G double prime is negative, therefore it's concave down. Okay? Good? Yeah, I like this stuff. This is some of my favorite stuff to do. Next one says G, they wanted the tangent line equation at 4. So if I want the tangent line equation at 4, this is H right now. So tangent line at x equals 4. What two things do you need to have the equation for the tangent line at 4? It's definitely J, thank you. What do you need for the tangent line at x equals 4? You need the slope. So I need G prime of 4.
Then the point.
I need G of 4. I think I figured those out already. Didn't I find G of 4? Yeah, part C. What was part C?
That was 3, wasn't it? No.
That was 5, I believe.
That was the area.
That was the area from 2 to 4, I think, was in area 5.
We got the slope.
Okay. Now, the slope at 4, well, that was really the same thing as f of 4, so you went and got the point. So what was the slope at 4? And you got it from the point. What was it? 3. So G prime of 4 is 3. G of 4 is 5. We already answered those. We answered it in C and E. So they're just building off of this. So what's the equation for the tangent line?
Y minus 5.
Y minus 5 equals
3x. Or no, 3 times x.
X minus 3.
No.
X minus 4.
How would you give me the normal line? Normal line. Normal.
Just
Ridiculous.
split the slope.
Negative 1/3 times x minus 4. Okay? Alright, let's go to the next one. I'm only going to get through the A through, I'll get as far as I can, and then we'll pick up here tomorrow. It's about where we got last hour, same place. Let f be the function graphed below by g of x equals the area from 1 to x. Where is this one measured from? 1. So I'd go ahead and do this. That's where I'm measuring area from. Notice the lower limit of integration. Yes, we know. Okay? In A through F, now here's what's weird on this one. In A through F, determine whether the following is positive, negative, or 0. They don't want number answers. Here's why. You can't find them. Nobody would be able to find the exact answer here. Can somebody tell me why? First of all, you don't have an equation. That's the first reason. You don't even have an equation, so you can't do the exact area of the curve. And even if you could do it geometrically, let's say I found the area from 1 to 2. Somebody tell me a geometry formula for that looking triangle. Do you have a curved triangle formula? No, I have to have straight lines to do a triangle. So you can only estimate. Here's how I want you to estimate. I just want you to do A through E real quick, as quickly as you can. Put if it's positive, negative, or 0. Positive, negative, or 0. Well, you got to answer the question. Some of them might be areas, some of them might be derivatives. Let's just do one of them, and then we'll come pick up here tomorrow. And how about just finish A through F real quick? It takes like a minute to do. Just have them done before class. Or remember, when you come back in here tomorrow at the beginning of class, just do them real quick so we can rattle off the answers. So I'll just do one so you can think about it real quick, and tomorrow I'll remind you. Just real quick, get that out and do it real quick. G of 1, for example. G of 1 would be the area from what? 1 to 1 of f of t dt. So what's that one going to be?
0.
And by the way, it says justify. Some of you are going to be like, how do you justify this? You just did. That is your justification. You wrote out how you're doing it. How you're doing it is the justification. An answer doesn't justify. An answer is an answer. Justification is how you got the answer. What would the answer be here?
0.
But look at G prime of 1. Now that's different. Because this is G of X. What's G prime of X? Help me, what's G prime of X? F of X again. So if I want to find G prime of 1, it's the same thing as, there's your justification. This is your justification. F of 1 is the justification. What is F of 1? Look at it, everybody. F of 1, if you go up to the graph, this point looks like it's above the, it doesn't look like, it is above the x-axis. So what do you put? Positive. And that's how you do C through F. So if you want to do C through F here real quick before we leave and just have it done before tomorrow. Just remember, I'm going to pick up right here and I'm just going to say the answer. So if you want a chance to try them, just do them real quick before the bell rings. And I'll go over them tomorrow. All right, homework tonight.